programs. Okay. Now, already you know that if I am going to delete an element, this requires that already the linked list exists. Therefore, assume that there are, say, already a linked list, which will be something like this. And here you are having a start pointer which points to the first node. Now, there are three types of deletion, obviously. One, the first node, second, a last node, and third one can be anyone in between. Now, anyone in between requires traversal. Deletion at end also requires traversal, whereas starting at the first, there is no traversal. Therefore, just try to, I will write this algorithm, the easier one first. Let us try to write this one. Delete the first node. Now it's too simple. What you're going to do, as you already know, you first of all put one pointer t over here, and I write t is equal to start. Then I just move start to the second node. If I say start is equal to start of left, so right. Then what will happen? Start will shift from here to here. And then I write return t to again. Now, before that, what I will do, I'll put a link null over here. Therefore, I'll say start of left. And then return that's all. No, that's all. That means these four steps are there. First, you make a pointer t is equal to start, shift start from first to second, start of left is equal to null, and return t to again. Now, this is simple. Now, this is the second algorithm will do, say, delete the last node. Now, if you remember in the single English, what we have done, we took two nodes. Sorry, we took 2 pointers, started moving those one by one, such that one pointer is before the second one. The moment that pointer reaches to the last, the other pointer was just one before that. But here, there is no need because already I am having a back pointer. Therefore, what I will do, I will just write a traversal till the end. And when I start traversal from t from there, I will be reaching t to this position. I will reach t to this position. Now you know that the standard way to traverse is the same. T is equal to start, while T of right is not equal to null, T is equal to T of right. So those lines are very common either in a single linked list or in a double linked list. Therefore, just what you have to do, you will just write T is equal to start, while T of right is not equal to null, T is equal to T of. Now these three lines are standard for the traversal. Therefore, if you want to reach to the end in either a single linked list or in a double linked list, this is the rule. Okay. Now here, once you reach to the T, you have to move T1 back. You can move T1 back. Now there are two ways. Either is that either of them is correct. What you can do, you can move T1 backward and then you can delete that. Or the other one is that from T itself you can delete. Okay. Now let us see the one that what I will do. I will just move one. I'll move backward. I will write T is equal to T of. Now once you do, T will come here. T will come here. Now after that, what you do? You have to do how many types? You have to do only two things. You have to do is that you have to first of all make this as null, and then you have to return that T, the old T, to avail. That means you delete this one. You have to delete this one. While deleting, you have to return that to avail. Now, here what you have to do is that once you have copied a null value at T, the T of right, you lose that address because this address, leaving address, suppose 2100, is saved over here. Is saved over here. Now, if I delete that, if I put a null at that point, I will lose that 2100. Therefore, there is another method. What I can do is that I can save that T somewhere. Now, what I will do is that I will save the T somewhere. Therefore, what I will be saving, I will say I will write a save is equal to T, and then I will say T of right is equal to null, and then return save to avail. Return save to avail. That's all. And by that, the node which is there will now go back to available area. Okay. Now by this method, you can very well try to use this concept to delete the last node. Okay. Now this is quite easy to do that. Okay. Now, if you want to delete in the middle, for example, I want to delete in middle. Now you have something like this. Okay. Now this is the scenario, and you want to delete any of the nodes over there. Just take an example. I want to delete, say, this node. Now what I can do, I can just start with, say, somewhere with a T, come to this position T, and then I will try to show you that with T on that node also you can delete. Now let us try to find what has to be done. Actually, when you want to delete this node, you have to maintain a pointer like this, and you have to maintain one more pointer like this. Okay, you have T at that position. Now you have already traversed. Let me write that. You traverse to the node to delete. That means you have reached T to the place you want to delete. Now, with T at that position, let me try to delete that node. Now, what happens? Suppose this address is given somewhere like this. This address is suppose this address is suppose 2010. Suppose this address is suppose 2400. Okay. Now this 2010 is saved over here, and 2400 is saved over here. Okay. Now what you will do is that you have to copy this value at this position. You copy this value at this position. But that value is already nothing but T of right. It is already given as T of right. Therefore, if I copy that value over here, what I will do, I can copy either this or I can copy either this. If I write like this, say T of now in this case, this value is T of right. Therefore, what I can do is that now what is this called as this part? This part, there is no name, but it is nothing but T of left of right. What is T of left? Is 2400. What is T of left of right? Is that part of the node before T and the right part of that. Therefore, this part can be referred as T of left of right. Correct? Because T of left is 2400, 2400 of right is that part. So similarly, this part can be referred as T of right of left. To be referred as T of right of left. Correct? That means those two things are there. Now, what you have to do is that you have to copy that 2010 into T of left of right. That means you write T of left of right is equal to this value. This value is saved at T of right. Therefore, you write nothing but T of . Now, once you are going to do this, what will happen? Now, this value will now go, this value will now go, and you will copy 2010. This will now go. Now, you have to copy whatever the address given for this node, you have to copy over here. No, not here, sorry, not this one. We'll copy here. We'll copy. Here. We'll copy 2010. Now what you do? You have to copy 2400 to this part. Now this is called as say 3 T of right of left is equal to 2400. Now where is 2400 stored? It is in the T of left. Therefore what I like T of. Now what will happen over here? This is going to copy 2400 over here. That's all. And then you are going to return T to avail. Now here, what you are going to do is that you are going to return T to avail. Correct? Is it clear that you can delete either from one before, which I did in the last algorithm, and I can also delete from the node which I have to delete. Now obviously you cannot do on a single linked list because there is no back pointer, but here we can do that because already there is a back pointer which is going to point to the backward one. And with this one you can very well try to delete any node. Okay, is it correct? Are these steps very clear? The only thing is that you have to write the first step, traverse to the node to delete. Now that is a very simple one. You already done in the single linked list. You just modify the conditions, and whatever is given, you are going to just put such a way that that is going to come to that position. Okay. Now that means we have already done delete at the start, delete in the middle, delete at end, and we have done all the three types of deletion, all the three types of additions, and therefore we can now only thing is that how you traverse the nodes. That is very simple. You just write the same, and if I say write, you have to print the data part of those things. What you can do, you just write a traversal algorithm, and into that body you write a printf statement. A printf statement to print the data part of the nodes. That is nothing but a traversal. Okay. Now, any questions? Because we have now covered all the algorithms of this. The basic algorithm we have covered: all deletion, all insertion, creation of a double linked list, and all the single linked list, all creations, everything we have done. Now, what remains to be done are the problems which are there.
Excuse me, sir.
Yeah.
Sir, for the transversal, sir, we need to transverse up to less than n minus 2, n by 2, no, sir? For the middle.
For the middle you can traverse, but see, I already told you if you are going to do for n by 2, it is going to take 1.5 traversals. If you are going to do one traversal, the algorithm which was discussed on that day, you take 2 pointers, move the fast pointer 2 times, and move the slow pointer 1 time. Now what will happen? When the fast pointer will reach to the end, the slow pointer will be at the middle. And therefore, by that method, you can do that. Just yeah. Did you get it? That means if I want to do it strictly in order of n time, you have to maintain 2 pointer, one at the as a slow pointer, one as a fast pointer. The fast pointer moves double the slow pointer. Therefore, you can always have it a difference of half over there. Okay. Any more questions?
Sir,
Sir,
yesterday you have given sir one question.
Hmm.
Sir, delete a node in the circular linked list at the end with constant time. Sir,
Yeah.
how to do that?
Okay.
How to
Let
check
me
that?
come. Yeah. Anyone wants to ask any more questions?
sir, the way we have done the deleted end of the double linked list here,
Uh,
sir, it will delete the second last node if we return safe to avail.
which one? Delete it. Delete the.
The deleted end.
Just a minute. Just a
So
minute. Let me.
because we,
Okay. This one.
yes, sir.
Okay. Let me check it out. I will traverse to the end. Okay. I am there. Then I move one before that. That means he will move from the last to the
Second last.
second last. Okay. Now from there, I am going to uh, now with this one. What I have moved over there. Then I will save T over there. Okay. Just there is a small thing is that I will write. Yeah, that's correct.
Yes,
That save is equal to T must be written before that.
yes, sir.
Okay, that is fine. Good. Now in that case, what I will do, I will remove this one, and there is a small things which has to be done. Therefore, I will write over here. I will write here. Uh, I will write over here. Save is equal to T. That's all. Now this will solve. What you are saying is perfectly correct because I moved left and then I saved the value.
Yes,
If obviously, or otherwise, what you can do over here, what I can do over here, I can write over here, save is equal to T of right. Or save. T of right means the last node. That means either I write save is equal to T of right, or if you want to use that, I can write save is equal to T before moving to the left. So that is going to solve the purpose. Isn't it not fine?
yes, sir.
Okay, now good. Now the question which I gave in the last class, I'll just try to solve it. Now the question was like this. You already given a like this. Now already you know that in a circular linked list there is no end. There is no end because circular. Therefore, what you have to do is that in that case, this might look to you that this is the last node, but actually this is the last node just because you start from where you are putting the start. Now here, if I put a start over here, it means that that is the last node of that ring. Okay, now this is just a ring. Now obviously, if I want to insert at the last node, I cannot do that. Now what I have to do is that I have to put a node over here. Now you already know that insertion at end will always take the order of n times. Now let us try to maintain the data for this. This is suppose this is 4, this is 10, this is 2, this is 8, suppose this is 15. And suppose I want to insert say 25. Now this you cannot do after 15 by using conventional method. Now what you have to do is that you have to insert 25 at this position. You insert this node, basically this node, at that position. And then what you are going to do is that you swap 4 and 10. Now what will happen? 4 will come here and 10 will come here. And actually you are inserting 25 after 15. No, not this one, sorry. You swap this one. Now, what is the node now? It is nothing but you are going to have the start will be pointed to this place. The start will now point to this place. Now see what are sequence. 4, 10, 2, 8, 15 and 25. And you have now inserted 25 after 15. Now obviously if you are inserting the as a second node, it is nothing but an order of 1. It's an order of 1. Just think of it. Fine? Is it okay?
Yes, sir.
Because actually you cannot insert at end in order of one time. Therefore, this is the only way out, that you have to make some modification. Of course, if I am having now what happens if you are having a ring like this? There is no end of this. If I ask you which is the end, you cannot say. Now it only depends that where is your starting point. Now here, if I am having say some value over here, say 4, some value over 10, there could be say 8, there could be some 20, there could be say 5, there could be say 2. Now obviously this is the ring. Now if I have the first element say as 4, this is the first element. Now if I want to insert after 2, you cannot do this directly. Then what I am going to do, I will be putting some new value over here. I will just putting some new value over here, and that value I will just swap with this one. Now I will maybe if I want to insert say 40, I will just copy 40 over here and 4 over here and shift first over this. That's all. Now you are inserted after 2. No, this is actually the same thing what is here. Correct? Now the other question what we have done. Can everybody do that? The question which I gave in the earlier classes. No, those questions are practice questions. Obviously, some of them have come in the exams. Therefore, you have to know that. Now, just I will try to give you the solution. I've already given one solution for the merging list. There could be one more solution, which is also a good solution. But again, I want more solutions for this. Now, the question was like this. You already know that. Now the algorithm which I gave in the previous class was order of n square algorithm, because for each one traversal of S1 you did for all S2. Now let us try to give you the second algorithm, which is little easier than this. That means the time is less than that, but obviously it is a algorithm which is a destructive algorithm. Now destructive means you are going to modify the things. Now what I can do in this one, S1 can be bigger or S2 can be bigger. Okay, both of them can be. Therefore, just what I will do, the solution is very simple. What I do is that I start traversing S1 and S2 both, one by one. That means I will start traverse S1 and S2 both. Once I am going to traverse S1, S2, what I will do, I'll modify the pointers of each one of them. Therefore, I will modify the pointers. By putting a minus sign, negative sign before it. That means, suppose this address is suppose 2210. Now this is suppose 2400. This is say 2610. This is suppose 2720. Now as and when I move from S1 to the next node, that part I will modify the address of this to be minus 2400. Now what is the question? Here you are having the address at this place as 2400. Here you are having an address 2610. Here you are having an address 2720. Now when I am traversing, what I will be doing, I am putting a negative sign with this. Now if S1 crosses, what will happen? You will have another address, suppose 2800, suppose 2900, suppose 3000. So what is happening is that here you find that this address is maintained over here is 2810. This is 2900. This is 3000. Now what will happen if S1 moves before S2? This value will be modified to minus 2800. Now when S2 will reach to that node, it finds that it is a negative address. Now when it finds it's a negative address, it knows that at that point only that S1 had traversed. And that means when S2 will move from here, when it reaches to this point and it checks the address of this node is minus 22810, it knows that one of the other linked lists has already crossed that. And it will just read the address 2720, and now it finds that 2720 is the meeting node. As its link contains negative value. It knows that this is the meeting node, because all addresses should be positive, but only thing is one which is now if S2 is smaller, then S2 will make a negative, will make it negative, and when S1 reaches to that point, it will find that is a negative address and it will read that address. Okay. Now since you are just modifying the sign, the address is not changed. Therefore, once you want to again make a traversal, you just convert all negative numbers to positive numbers, and it remains the original linked list. Okay. Therefore, it is destructive. But when I say, it means that you are modifying it, but not completely modifying. You are just modifying. Now, if I want to again traverse, what you do? You just read those addresses. The addresses will be negative, and what I will do, I will just start converting all these as positive. And now it will be like an original linked list. Therefore, this is one solution. Is it okay? That you can find by just modifying the addresses. But if it is said that you cannot modify the addresses, then you cannot do this. Then you cannot do this. Or it is, you can also modify the data part. For example, you have a data. You might put some added, you might add some character to that. For example, if a node is something like this, maybe it contains, say, 2400, and it contains maybe A. Suppose this is the node. What you can do is that I can put some sign. I might put a hash sign over here. As and when I traverse, I just modify the data part from A to A hash. Now, once in that case, each and every node which is there in the thing will become an hash. And now, once the next list will reach to that point, you will check the data part and will find that there is a hash. It means that is a node. Now, in that case, all the data part will have a suffix of some character which cannot be there in the data. You might put a hash, you might put a comma, or any characters which is there, which is not there, and you can do that. Therefore, either you can modify the address by a negative value because negative addresses cannot be there, or you can modify the data part by putting some special characters, a dollar or a hash, a comma, maybe a full stop, anything which you feel that is not there in the data part. And you can do like this. Now, this is the second solution. But I want more solutions for this. There are other than that, there are more solutions for this which you can try to find it out. Okay. Now with this, I think we have covered all the. Now tomorrow I'll cover some of the questions and also try to show you some programs, small programs, just for your know. I already told you that program is not a part of this syllabus. The programming will is only there, but I taught for the pointers in the initial class, the first, second class. After that, the pointers are no more there. Therefore, the programs are no more there. Just I'm trying to do, because once you are going to start the lab, this all becomes a part of the syllabus, of a lab syllabus.